可能就要离开慢慢这
这个有饭吗？这个饭够
别人的，
够50个人。
一人一口。
你外卖要点吗？一个人，这种测试都常人讲，第六这样子就2.9，大二这样子，你这样子来给压力哦，你给压力哦。
压力啊，no pressure，no pressure。
这个不 prepare，这个我就不会抄一个词了。这个 preparation 的
sharing 吧，sharing 弄。
没有哦，等下你发出一点声音，这个才一个人在上每个人站在我旁边。
对，那你跟我外婆从来没有理我哎。那是进了去啊。
可是你的，你至少要一点别人成长。
是这样的出来说不这样的。
对咯。
要成长，我可以事后再告诉你啊。爸爸，你现在不可能，我跟着你家了吗？对不对？我不能跟着你去社会嘛。不过，对对对对，因为我帮你回答跟你的，所以我就把微信欠今天的东西。
这样他会叫他发照片。
他那只是来录个脸，来 support 掉。对，反正
感觉会很多。
就是时间生活上面，
我觉得你的全程这样很短。可能也是。自己，你要计时还是要搞定？就叫你讲。
这样升高。
时间的话，如果 start 的话就开始了，1秒半个。我们现在之后了，啊，然后半个结束，不给他再半个钟。 方面的讲，
当然眼睛神奇，
对，
这个可以。
然后我就讲尝试，是个第1秒半来2次游戏的交流。看过人家辩论赛，
我有
辩论赛，就类似那种。好变化。不然他讲不了就讲完了，然后1分多，最多我们可以还有到2个，就3分。所以他们这方面讲完30个，因为我们在音乐听到了，感觉。
你大声，
但是我猫这个是够不够的呀？看一下。现在还需要一个电脑，还需要一个电脑。没有问题。
到3D，
对。
这样我这个人是，就把我们的那个麦克风把这个人再说。
要有近期的话，有加注意点。刚谁？
有声音，
声音啊，要插头，要插这个，要声音的，就不需要这个，要插这个。试下你的 video，试下你的 video，我试下你的 video。testing。 Oh, sorry, we'll be late a bit. There's a delay. People haven't come in. Do we have most of the people here? Maybe we wait for another 2 more minutes. Okay. I think not all the MIT students here yet. 离开了没有 Syed, where's your PPT? Maybe open yours first. What's the name? Maybe you ready here first. Yeah. What's your name? Hello, testing. Okay, I think we should start soon. Okay, good afternoon to everyone. So welcome to MAT103 Calculus 2 seminar. Okay, so today we have 42 persons who are presenting. So basically we break into 3 groups, 14 for a group. Okay, about 1 hour we will finish each group. Okay. And then everyone will spend 1.5 minutes to present their content. Okay. So after 1.5 minutes, we will straight away cut your talk. Okay. And then for the rest, we will ask in Q&A section. So Q&A section is about 1.5 minutes, but we can extend until 2 minutes. Okay. Yeah, we can extend further for Q&A section. So everyone can ask question. So I will ask first, and then the MAT student will ask. So because I have extra mark for them if they ask question. Okay, for MAT student. And after MAT student, then AIT can ask, and then all the rest can ask. Okay, and we should welcome a lecturer from Tao Shen from mathematics. Yeah. Yeah, yeah. Yeah. Okay. Thank you for Tao Shen for coming. Yeah, so today we will have two timekeeper. We have Yanjing and Yujing helping us to type the time. So you will hear the bell sound. Try. Okay, to alert you whether finish or not. Okay. Once one times bell ring, so you should signal that you should finish soon. Okay. Two times bell ring, you should stop. Okay. And yeah, question times. Yeah, I think that's all. Yeah, any other question? No. Okay, so we will have Jiang Chen helping to monitor the technical stuff. Okay, so for all the speakers should refer to him. And yeah, so since we are all here, before we start, could we take a group photo first? Quickly take a group photo. Yeah, before we finish. Scan letter gone, huh? So can everyone just move? No need to bring your stuff. Just move to the middle. And then we'll take a group photo. Maybe Taoshan can come to the front. Ah, you tell her. Okay, sure. Okay, it's okay. Yeah. So, can you guys quickly move to the middle and then we take a group photo. Then before we. Yeah, going, coming also. Yeah. Okay, I guess we take a formal one, then we take a informal one. Oh, quick. I know I need to be away at 2, so. Hello. Okay, so we will have two mics here. So after the speaker finish, right, you please turn off this mic, because if we are going to use second mic, the other mic have to turn off. Okay. Yeah. So if you already finish speaking, if you're not speaking anymore, you turn off this mic, and then the other mic can turn on. Okay. Otherwise, we can't use two mic. Okay. So let's get started. So we have our first speaker, Hugh Sayek. So he will tell us about the how to deform a regular photo to an ellipsoidal photo. Sorry. Yeah.
Good evening to everybody. My project title is deformation of a rectangular focal to an extrasocket focal. Most focal in the world are rectangular. However, for artistic reasons, one might want to convert them to circular or extrasocket focal. Before that, we need a square to this mapping F. Now this F is a conform a square to this. We need to scale the rectangular focal to a square focal, then use the square to this mapping to conform it to circle focal. Finally, scale back the circular focal to isosceles focal. This is an example. For this example, we can see this mapping keep the focal intact, although the focal has significant step discoloration near the corner. Thank you.
Okay, thank you, Syed. So any question for him? Any question for him? Oh, I forget to mention to all of you, right? So I have a personal agenda. So I want to know everyone why you study maths. So everyone will have the chance to answer this question after their presentation. Oh, testing. Yeah, could you please tell us why you choose maths to study?
I'm gonna choose what to study, so I just math.
Any other question for him or not? Academic wise or yeah, academic wise. Yep.
Yes. Actually, how can we see the transformation of the image from the function you gave?
So the question is, can you tell us why, how to see the transformation of the image from the equation? Is it? Yeah.
The square grid to the this square of the accelerated grid.
Okay. Okay. Thank you. Yeah. More question. Okay. Last one. Last one.
Transformation handle the exceeding part. So because you see the square outside, the outside of circle has exceeding part. How you handle that?
The square function had no point to include in the absolute.
Okay. Thank you. So thank you. So everyone should check the schedule. Please be ready. Who's the next one? Okay. So next one is Ding Yu. So he will tell us about tutocron cycloid. Please be aware which speaker is before you. So please be ready.
Good afternoon, everyone. My topic today is tautochron cycloid. On a tautochron curve, objects sliding down from any position take equal time to reach the lowest point, and the curve is proven as a cycloid. Here is a motion on the tautochron curve. As we can see, these balls start sliding at different positions, but they reach the bottom at the same time. To prove this curve is a cycloid, we first take this equation and assume theta be the angle between the velocity direction and the horizontal line. Therefore, we can have the derivatives of s, x, and y as shown as equations below the graph. Okay. If we solve these equations simultaneously, we will get this parametric equation for xy, which is actually a cycloid. Also, if we calculate it, we can find the time needed for an object to reach the lowest position. That is pi times square root of r over g. Thank you.
Hello, any question?
Maybe in industry, let me continue with an example. I think it can be used in the design of block, as we need to count the time with average rate. So we can use this property of cycloid to keep the time goes like this.
Help me to ask.
Okay. The reason for me to study math is it's mainly because I enjoy the logic embodied in math. I think logic is for example, improves we use logic to explicitly inference of a step and okay, continue. Therefore, we can ensure our proof is correct. I think with logic, we can explain what we see and to guess what we can see. Is where math really attracts me. Yeah. Oh.
Next, we have Ziqian talking about brachistochrone cycloid.
So I am going to share this brachistochrone property of cycloid. This brachistochrone is a Greek word, so it means the shortest time. What shortest time? Like we have 2 points A and B, and we have a ball rolling from A to B. So what curve the ball can roll the fastest to B? Maybe you will think it is just a straight line. No, because this path has the shortest length, but it is not the shortest time to reach B. So actually we have some physics and we can see the last line. We can see the time is a function of x. And it is also a function taking y, but this y is a function of x. So we have a function of function. So this is actually quite hard, and Euler has give a solution. It can solve by solving this Euler-Lagrange equation. So actually, we can find out this curve is actually a cycloid because we get this parametric equation. So cycloid is just having the curve like this. We have already learned in the class. So why I learn maths? Actually, I will just put this joke to you. And actually, I want to show maths is giving us a great inspiration. It has many things. It might be intuitive, but actually does not. It is the fun of learning maths, and I hope you all will enjoy it. Thank you.
Okay, thank you, Ziqian. So do you realize that your curve is the same as the Dingyu's curve? Are you guys solving the same differential equation or not? So it's not the same equation, but they somehow give the same answer. Do they get the same constant or every constant will work? Is it the exact cycloid that thing is getting or not? It's just one the other type. Yep. I see. Okay. All right. Okay. Any other question? Can take one more. Okay. That's all. Thank you. Got a question? Question. Okay. Thank you. Okay. Next up, we have Ryan telling us the design of gear system.
Hello. Good afternoon to everyone, and today I would like to talk about the design of the gear. And first, I would like to introduce about the epicycloid. Epicycloid is the red curve that met by tracing the fixed point T of the black circle, which is drawing outside the blue circle. And this is the parametric equation of the epicycloid. And from the equation, we can assume that a ratio K is equal to A over B, which A and B is the radius of fixed circle and the rolling circle. And from the examples, we can see that K values can control the rolling of the number. Yeah. And we apply the concept to the gear system, and we can imagine that there is a fixed point P on the red gear, and they were moving like epicycloid. Okay, and for example, this is one part of the gear system inside the gearbox of the car, and they are applying the concept of epicycloid in their design. And so first, we have to find the suitable value for the ratio K to compute the number of T and pitch diameter to ensure the proper machine between the gears So this is how we apply the epicycler concept to the gear design. That's all. Thank you.
Okay, thank you. Any question for the gear? Any question? Any question?
To win this, this is outside, right? Yeah. Next one. Oh, this one is one example from the gearbox of the car one. So you can imagine, if I want to introduce this, the middle one is called sun gear and the green one is called planet gears, and they are controlling your speed. Yeah, it's very complicated if I want to, because you can imagine, you don't have to include the red one gear. You just see the green and the yellow one. Yeah. For okay, first, math is the best subject during my high school time, and my favorite subject is maths. And after I graduate from high school, I have no idea which course should I choose for the university. Since the teacher told me that math course in XMUN is not a pure maths, it's like applied maths. So we can choose many major elective in this. So I choose the maths course. But after 1 year, I study maths. Um, my no regret. But my interest in maths is become more lesser than before because since maths is become my job already, not my hobbies. Like high school, I can choose to study maths, not bio like this. So however, but I still didn't think to change my course because I still loving the maths. Okay.
Okay, thank you very much. Yeah. Yeah, I feel the same too. Okay, next, Iron. You will tell us about split wheel bike. Split wheel bike. So how can a bike with a split wheel run on the road? Okay. Hello. Wait. Okay. Today I'm going to talk about the parametric equation in real life applications. And so now the problem statement is now we want to build a bike with the two split wheel at the back. And so the concern is about we want to, when you're cycling, you have to always stable when the back two splits wheel. And now we want to do the simulation to see how the two-speed build is stable and unstable. And so the two-speed build is the semicircle. So we can generate the circle equation and let x minus k and y minus h is a parametric equation of the circle. And now, since I want to simulate, and so I fix the center of the point and radius 2. And now this is my simulation of the two-speed wheel. And this you can see the unstable case is the
view at the end point when you cycling, the first wheel will lift up and the second wheel is exactly touching the floor at the same time. So this will cause you unstable when you're cycling. So the stable case is we fix the second wheel to be more before the first wheel lifting up, so we can make it more stable. Yeah, it's quite abstract. Okay, this is the simulation of the two split wheel when he want rotate. Okay, this is the graph, and at time 6 seconds, you can see the first wheel lifting up and the second wheel is exactly touching the floor. So this will ensure the bicycle cycling always stable. Yeah. 3, 4. Okay, this is the simulation of the two-speed wheel bicycle, and parametric equation actually apply in real life or in many aspects, but mostly is in physics and the motions question. Yeah. So parametric equation mostly can make you to find a graph of the position of an object over the time. Yeah, that's all. Any question? Okay, why I study maths is because I'm interested in mathematics, and so I choose to study maths instead of other subjects because I don't know whether I have patience in study other subjects, so I just keep doing maths. But now, so far don't have idea whether I will study a pure maths or applied maths. Maybe I will wait until SEM 2 to decide. See. At the moment, I still interested in maths or not. Yeah, that's is why I study maths. Yeah. 金融 again, pardon. Actually, I also have no idea why you want to build like that because this question I get by kissing found in the internet is some engineer they interested to split the view to the half, and I don't know is it the efficiency or other things. Yeah. Video, but will take time is in the YouTube. Yeah, if you're interested, you can go to find. Yeah. Mm. Okay, thank you.
Hello. Okay, next up we have Zhe. Okay, Zhe will tell us something about consumer surplus.
Testing. Okay, selamat datang. Sorry. Good afternoon. Today I'm going to introduce the idea of consumer surplus. So let's see what is consumer surplus. Okay, I give you an example. So if you want to buy a roti canai, okay, then your expectation price is about 3 ringgit. But after you went to the shop, then you buy the roti canai when the exact price is just only need 1 ringgit. Then your consumer surplus is 2 ringgit. So the consumer surplus is the difference between the exact price and your expected price. So now let's consider the quantity be more larger. So the y-axis, the P means price, and the x-axis means the quantity. So when the quantity become larger and larger, then you want to compute your consumer price. The consumer price is exactly about the area of this one, this rectangle. And then, so you want to find the area of the rectangle, then you require the calculus. I think I need to tell you more about this graph. And then here, can you see a rectangle here? This P times Q. No, P, Q. Sorry. Okay, I give you see the picture here. This one, P times Q. This represent the exact price. Hello? So you want to find the area of the pink region which represent the consumer surplus. So let's see for an example. Okay, here is the
Okay, thank. Hello. Yep. So, why is it the price going down? I think China 3 ringgit is quite expensive. Okay, any other question?
reason why I want to study math because my favorite subject is maths. And then I want to learn the skill of solving problems so that I can enhance my skill in solving problem. Thank you.
Hello, thank you. Thank you, Zhexian. Next up, we have Shun Lin. Shun Lin will tell us about installment loan. Okay, installment loan.
Hello. A very good afternoon to my audience. So today the topic that I'm going to talk about is installment loan. First of all, you need to know that when you pay the fixed amount of periodic payment, the money will be used to deduct the interest before you pay the outstanding balance of loan, which we call it as principal payment. So we have the formula of principal payment, which is the term of geometric sequence. As the sum of principal payment is the amount of loan, therefore, we also have the formula of installment loan, which is the geometric series. This formula is very useful as we can use it to find the fixed amount of periodic payment by fixing the period of paying the installment loan. The formula also shows that the bank will charge more interest if the borrower wish to pay the interest with a longer period. So next, I'm going to talk about why I first chose to study maths. For me, I'm not that passionate to study maths, but at the same time, I'm also not that passionate to study other course. It just comparing with other course and maths, I'm more willing to do maths. So go back to the question, why I first study maths. It's because of my intuition asked me to do maths. That's all for it. Thank you for listening.
Okay, thank you. Thank you for your answer. So any question? Yep, Ming Xiu. Huh? Okay, Ming Xiu first.
This formula actually a bit complicated. I briefly say about. So R is the periodic payment, I is the interest rate, M is the conversion period, T is the time which is in year. So for M, right, I need to briefly talk about the conversion period. For if like the bank asks you to like pay the interest and the bank say he want to compound semi-annually with interest rate 16%. So you use the I is like 0.16 divide by the conversion period, which is semi-annually. So you divide by 2. So M is the conversion period. And T is the, actually is the year lah. Yeah, something like this. A bit difficult, but actually this one is look at the installment loan. So for example, right, you think about like you borrow 6,000, and for my project, right, I calculate you the bank compounds semi-annually, so it's like M equals to 2 with pay with 3 years. So the periodic payment actually is around 1,000 something. And finally, you add up, you will get like the final, sorry. So the how should I say? So I give it like two option. One option is compound semi-annually. The second option also compound semi-annually, but it's like longer year. By you think about I divide by M is like 0.08. MT is 1 is 6, 1 is 3. You calculate out the R, actually is different, but when you add up everything, for the MT is 6 and the MT is 3.1, you add up everything and you like minus out the installment loan, you will get like the MT equals to 3 is lesser than the MT equals to 6. Yeah, something like this.
Okay, thank you. Thank you, Sun Ling. Yeah, Sun Ling, you should label all your indices you have used, even though you cannot go through them. So next up, we have Ellie. Okay, Ellie will talk about engineering, physics, simulation software. You change topic. Okay, change the topic last minute. What's the topic? Okay, still physics. Okay, Taylor series in physics.
Hello. Okay, I'm presenting application of Taylor series in calculation and physics. And let me see. So the Taylor series we learn from class is basically what I wrote here. So I just skip this, and this is the definition. For Taylor series, it can be a power series, but a power series can't be a Taylor series. And this is just basically the notes in class. And why we use Taylor series in real life application is because it makes us can approximate solution to differential equation, which we also learn in ODE classes. If you didn't learn, then later QA you ask. Okay, and the another reason is It is also useful for determining various infinite sum. This is also we learned it in classes. And this one is we didn't learn in class, and this is for determining limits. But this is quite useful in physics. You can see here for the sine x, we can just apply the Taylor series formula and we can get the limit to become more easy. Okay, if a system under a conservation force is at a stable equilibrium point x0, then there are no okay. Yeah, and the energy function U center at that point, we can write it as a Taylor series. But we know that for physics, there are some displacement which can be big or small. But in this situation, we assume that for small displacement and the higher for higher order terms will be very small and can be ignored. So we can approximate the function to the first two terms.
Okay, thank you. So any question for her? Yeah.
Well, I basically love computer more than maths. I learned computer 2 years before I study here. And I have struggled studying online courses, and I think I need a start for it, a restart. And I can still learn computer because I still love the computer more than mathematics. But I know that computer programming language, we need a lot of mathematical solution and logic thinking. This is quite true. Basically, for like higher language, like for nowadays for AIs, I think like also in linear algebra, but I didn't listen at the course and at all. Some application and theorem is quite very useful in computer. It can like simplify a lot of things in computer that we just write a lot of equation and calculating. Yeah.
Thank you, Taoshen. Thank you, Taoshen, for coming. Okay, one last question from Jimbo.
For this Taylor series and like ODE we presented for the project, the most thing I think I learned in mathematics, I see mostly and mainly in physics. I can tell that because I have taken some physics courses before, and there are a lot of mathematical theorem that can be used in physics. Like for real life application.
I also have an opinion on this because you see that sin x, the expansion of sin x is odd number, right? So the first term is x, but you divide by s cubed. So you can see that the troublemaker problem here, x over s cubed is 1 over x squared, but it gets cancelled out by x before you take the limit, I mean. Yeah. Thank you, Ellie. So next up is Ying Ying. Ying Ying will tell us about the Great Pyramid, the favorite topic I like. Great Pyramid. Hey.
Is this? A very good evening to my lecturer and my fellow friends. Today, I would like to give a short presentation about the golden ratio in the architecture of the Great Pyramid. The golden ratio was proved that it has a relationship with Fibonacci sequence by Robert Simpson, and the Fibonacci proportions will converge to a limiting value as the terms becomes larger, and here comes the golden ratio. There are studies shows that the Great Pyramid was built based on the golden ratio, and this is the dimension of the Great Pyramid based on the average published data. By Pythagoras' theorem, we can obtain the length of the slang, which is A, and the proportions of the length of the slang with the half base length is approximate to the golden ratio. From another perspective, according to Herodotus, the square of the Great Pyramid's height is equal to the area of the triangular lateral side. Therefore, by Pythagoras' theorem and from the equation 1 we will obtain this equation 2. Now, when we let x equals to h squared over b squared, and by solving this simple equation, we will obtain x, which is the golden ratio. Therefore, we can also say that the square ratio of the height and the half base length of the Great Pyramid is also a golden ratio. So it is believed that the application of golden ratio in architecture is to create aesthetic details and to achieve beauty and harmony. And it is also further used in architecture of Taj Mahal and Parthenon. So that's all for me today. Thank you.
Hello. Okay, thank you. Any question for her? Question from the front.
Hello. Oh yes, because it's just a ratio. If you fulfill the condition, you can use this ratio to build a smaller pyramid. Because the pyramid is just a very mystery building and it's just a history. So now, because the pyramid is just a resting place for the pharaoh at the Greek time. It's the resting place for the pharaoh, so it's not necessary now for building a new pyramid.
How about we build a pyramid hotel? Commercial pyramid hotel.
Then you can refer to the Sunway Pyramid building.
Is Sunway Pyramid building looks like a pyramid? Any other question? Yeah, from the back. Yeah.
Hello. Because for arts and architecture is a best ratio to create harmony and beauty. And you can observe that it's also used in many things in real life like lift or other building like Parthenon and so on. Actually, my interest is Actually, my initial interest is in art field, like in architecture or illustration, although I'm a pure science student since secondary school. But due to some reason, I cannot make it at that time, so I just chose mathematics as my major as long as I not really hate mathematics. And now I just want to just survive for this 3 years degree and so.
Yeah, thank you, Ying Ying. So Ying Ying mentioned about Parthenon. So we have Grace to tell us about Parthenon in Greece.
Okay. Good afternoon to everyone. My name is Grace, and today I'll be discussing the application of the Fibonacci sequence in one of the most famous works of architecture. So it's the Parthenon of Greece. As we saw in the previous presentation, the Fibonacci sequence allow the golden ratio to be derived, and this golden ratio, as mentioned earlier, also helps create aesthetic works in many forms of architecture. So the golden ratio helps to derive, it can be observed in a lot of shapes. For example, the golden rectangle and the golden spiral. And the Parthenon, specifically the ratio of the Parthenon's overall height to its width, it follows the golden ratio. So this entire structure can fit into a golden rectangle. And then the Fibonacci spiral also can be observed in this image. You can see that the overall facet of the Parthenon, it fits into the spiral. And there are also smaller golden rectangle of different dimensions. So you can see in this one, you can see there are smaller golden rectangle in the more decorative part of the building, the upper half. Yeah. And yeah, that's it from me. Thank you.
Hello, thank you. Okay, so thank you for your presentation. So I have a question first. So do you think that this design is a result of design? This is the result of first putting into this theory to the design, or only after the design they think that this is more suitable for the building, then the theory exists. So basically my question is, the theory come first or the building come first?
I think back in those days, the building comes first. Yeah, I think the Greeks, since it was built by the Greeks, and I think it existed for like 2000 plus years. I think they didn't know at the time. But yeah.
Okay, thank you. Any other question for her? Yeah, from from Yishun first.
I think maybe it will take a lot of time and work, and also the golden ratio, they are using it to apply more in other fields, like not so much in buildings. It's more like in like web design, and they are using it in other fields. Yeah, not so much in the buildings. The stability, actually, when I did research, I did search for this. I couldn't find article saying that it increased like the stability. They did say it make it more symmetric. Yeah, but so far, yeah, I not sure about that.
I guess someone should do a research on this. Build a golden ratio building and then do the research. Because these all building are quite old already, so you can't do much research. So maybe you should build one and then try and do research on it, whether it increases. I need money, okay? I need money. Jimbo, you got question?
To be honest, through high school and foundation, all my subjects, like my science subjects and my math subjects, the grades are all quite close. And so before I entered German also, I didn't really, I'm not sure which one to choose. Yeah, but after considering, I found maths like slightly more interesting, and I enjoy that it uses the logic to solve the problem. Yeah.
Okay, thank you. Thank you very much. Yeah, next up we have Xue Mei. She will tell us about golden ratio in human. In human.
Okay, good afternoon, everyone. I'm Shuemei, and today I will talk about the golden ratio. So the golden ratio has a wide range, and today I'll be taking exclusively about why women like to wear high heels. Boys are also relevant to today's topic because you must know how to choose the most suitable high heels for your girlfriend or mother. So what is the golden ratio? Golden ratio is a relationship between two numbers with an approximate value of 1.618. So why do women like to wear high heels? So there are three reasons. So the first one is high heels can enhance their figure, and wearing high heels elongates the legs and bring their body proportion closer to the ideal proportion. So the last one is women who wear high heels will walk faster and avoid falling, which make women walk with grace and dignity. High heels are popular with women on formal social occasion because they enhance their attractiveness. So how to choose the right high heels for yourself? So first, make sure your leg length, which is the length from your belly button to the bottom of your feet. Then apply the golden ratio formula. So calculated figure is the most suitable height for your high heels. So you guys can remember this formula or search on Google and then calculate for yourself or for your mother or girlfriend. Okay. So that's all from me today. Thank you for listening.
Oh, thank you. Any question for her? Yeah, Wai Ying.
Hello. To be honest, mathematics was not my first choice. And why I chose to study mathematics because I thought it was very interesting. And mathematics is also a very good basic for postgraduate study. But I'm not sure I will study for it or not lah. So I hope I can learn something from this course. Yeah, that's all. Thank you.
Any other question? Yep, from Ellie.
I don't see this movie before, but I think it is possible because beauty beauty is the most important thing. Yeah, this is my opinion.
Any other question? Okay, more from Jason.
I guess, I think, yes. Yeah. Thank you.
All right. Yes, beauty, the most important thing. Max is beautiful. Okay. Next, we will have Guli. Okay, Guli. Talking about Fibonacci sequence in plants. In plants. Okay, let's see how golden ratio get shown in plants.
Today, I'd like to talk about the Fibonacci sequence in plants. You may have noticed that the number of petals in many flowers seems to follow a specific pattern, such as 3, 5, 8, 13, 21, and so on. These numbers appear to have a mystery connection. A Fibonacci sequence is a series of numbers in which each number is the sum of the two preceding numbers. The ratio of adjacent numbers in a Fibonacci sequence approaches the famous golden ratio of 0.618 as the number increases. The golden angle is derived from the golden ratio. The divergence angle between consecutive leaves often approximates the golden angle. This arrangement ensures optimal exposure to sunlight and minimizes shading between leaves. The number of spirals in each direction is usually consecutive Fibonacci sequence numbers. Sunflower seeds radiate along a spiral trajectory with an arc of 137.5 degrees. Only when the divergence angle equals the golden angle, the distribution of seeds on the receptacle is most efficient. Thank you.
Okay, hello, thank you. Yep. Any question for him? Yep, on the back, Ito.
Because math is a basic subject and because I didn't have a clear plan for my future, and my parents say learning math is good for your future job, so I learn math.
Hello, yep. So you are an obedient son. Is it? Obedient son. Okay.
Most flowers. Yes.
Hello, no more question anymore? Okay, thank you. Thank you very much, Guli. Okay, next up, we have two more and then we will take a break, okay? Next is Jiawen. Jiawen will tell us about perturbation theory in astronomy. So we are going to space now.
Hello. Okay. Good afternoon, everyone. Today I would like to talk about orbit perturbation. Okay, look at this picture. The ellipse is the idealized or the original orbit, and there exists some perturbation, so the actual orbit is different with the original orbit. We consider an example of a binary star system, and we want to study the motion of a planet in this system and the perturbation caused by the companion star in this orbit. This is the planet motion equation. And we consider a small parameter epsilon to represent the perturbation caused by the companion star. And we explain the planet position as a power series. By substituting the expansion into the planet motion equation, this is the example of a first order perturbation term. Actually, this perturbation theorem is very complex, so this project is only for visualizing perturbation in planetary orbit. That's all. Thank you.
Thank you. So any question for her? Yeah, from the back.
Okay. At first I choose mathematics because I think I love mathematics. But after semester 1, I feel a little bit confused. But now I still find the reason to continue study mathematics. Yes. Um, the ellipse is the idealizing original of sorry. Okay, the ellipse is the idealized original orbit, but then there exists some perturbation, then influence the orbit become different with the original one. Yes.
Yeah, I have got an idea. So is it like so do you mean that the planet experience some perturbation? Is it? The So it seems like the perturbation theory for the planet have something similar with the uncertainty principle of atom. Can I say so? So that's why you have this power series and never-ending term contributing to the position. Thank you very much. So thank you, Jiawen. Next up, so we need to go from planet to quantum field theory. So we have a last one for the first slot, Shi Yu. will tell us about vacuum energy density in QFT.
Christine. Okay. Good afternoon to everyone. And today I'm going to talk about the Ramanujan summation in quantum field theory. So first of all, consider one-dimensional case of Casimir effect. From Wolfgang formulates that vacuum energy is equal to the following formula. And the following figure is the illustration of 1D Casimir effect. But the question is, how do we deal with this divergence series to get a more sensible result? So before we go into that, we can we will talk about we take this as a sample to further explain what is actually a Casimir effect. So basically, Casimir effect is that you place two parallel uncharged plates in a vacuum, and then within a very small distance separate between them, and there is an attractive force exists due to the quantum fluctuation, as illustrated in the figure that I shown. Then next, before I get into the solution, we need to introduce the Ramanujan summation. So basically, Ramanujan have found that 1 plus 2 plus 3 plus 4 plus until infinity equal to -1/12. But turn out that Ramanujan summation is not like doing usual summation. So get to our solution to the problem. So basically, we use regularization, which is a method of modifying a divergent term to be finite. So we use that regularization and renormalization. We obtain that Casimir force in one-dimensional case is approximately equal to -pi/24 d squared. Negative here shows that Casimir force is attractive, which makes it consistent to the prediction by Casimir. So basically, we use we somehow do the regularization on the Riemann zeta function. Is somehow consistent to the result that found by Ramanujan that 1 plus 2 plus 3 until infinity is equal to -1/12. Yeah, that's all for me.
Thank you. So any question from the audience? What's that question? Yeah, any question?
So you see there's two equations, right? In C here represent the summation of n summation of all natural number, and from 1 we can get to by multiplying 4, and so now we take subtraction between the two equations, like we minus 2 minus 4 and 4 minus 8. So we take the even terms minus the second equations, and we will get -3c equal to 1 minus 2 plus 3 minus 4 plus, and so on. Oh, you can recognize that this is actually what we have learned in our calculus too. This is a power series of 1/1 plus s and bracket and square. 1/(1 plus s square. Yeah. And you do continue, then we get the result. Yeah.
Yeah. Ming Xiu.
Actually, this is not like doing usual summation, and actually we introduce a parameter which called regularizer in this summation. So after that we do, so basically in this we do renormalization to eliminate the counterpart of the parameter that I introduced in the summation, then we will get to get a more sensible result for this experiment. So it's not like your usual summation that we do in mathematics. It's like we introduce some parameters or limit and make it approximate to 0, then we will discard all the extra stuff in the summation. Yeah, a bit complicated, yeah.
So do you mean the C is the regularizer?
This in this context, C is introduced by Ramanujan, which he denoted that as the summation. Yeah, summation of, for this case is summation of all the natural numbers. Yeah.
So last question.
Why I do math is because that I enjoy the process of inquiry math knowledge, and I wish to do research on math in the future. Yeah.
All right, good. So we finished. Thank you, the speaker. So we finished our first slot. So let's come back, take a break, toilet break until 2:35. Okay, we'll come back. Resume at 2:35. So the first speaker, please be ready later. So it's Yuan Jia telling us about 12 tone equal temperament. Then later, please be ready. 2:35, 2 o'clock and 35. hello, testing. Present. Yenjia, someone says that your slide got missed typo. Presentation. Your presentation got typo. Yeah, okay. So right. Okay, so we should start now so that we don't waste time. So let's start with first speaker. Yeah, so let's start with first speaker in the second slot. We have Yuan Jia to tell us about geometric series in music.
Today I want to introduce geometric series in music. Since there's a slight difference between high do and the sharp C in Pythagorean tuning system, during performance it will sound very unpleasant when transposing music. Due to the human ear's higher tolerance for pitch deviation in individual notes and lower tolerance for interval deviation in harmony and transposition. So people began to wonder if it's possible to create a temperament where even each note would be slightly off from the ideal state, but the intervals between the notes would be equal. Assume that the frequencies of do and high do are respectively 1 and 2. We consider frequency as distance between two notes. Then how to find 11 notes between 1 and 2 such that the distance between them are equal? The answer is geometric series. The number 1/2 to the power of 12 is the multiplication factor for frequency increase between each note. Such the system where the distance between each note is equal is called the 12 equal tempered. It's widely used in music. Thank you.
Thank you. So any question for this? Any question?
I think math is useful. It can be applied in many fields in reality life.
Okay. Question about the slide, Kyron?
Q is the multiplication factor of frequency increase between each note. Finding Q to ensure the distance between each note is equal. What? Because for the harmony of the music, when you transposing the music or the harmony.
All right, so thank you. Hello. Okay, thank you, Yuan. So thank you, speaker. So next we have Yongzi. Using Fourier analysis. Fourier analysis in music. Have we done Fourier analysis in this class? Okay, Fourier transform. Sure.
So I'm giving an intro to Fourier analysis in music. Fortunately, Yuanjia just introduced the first part I was about to tell you guys. The thing about pitch is each pitch has their own frequencies in sound wave. So and we can form this recursive sequence, and this tuning system we call equal temperament. Yeah. So these are some examples of chords. To analyze a music, chord detection is a very good way. So about Fourier transform, it let us convert a time domain function into a frequency domain function. So since frequency can means a note's pitch, so we use that to determine what notes are being played at that time. So we imagine plucking a string of an instrument like a delta function. We define it like this because at the time, how do I explain this? Okay, so I just walk through the other steps first. We do a linear combination of this delta function as a function of time. Then when we perform a Fourier transform on this function, then we can get this discrete Fourier transform equation. Then since we need a time domain function, we use this trick called a short time Fourier transform to introduce a time dimension into our graph. So the top one is a spectrogram and the bottom one is a chromogram. It basically, the difference is in the y-axis. The spectrogram, y-axis is its frequencies, and this chromogram indicates its chroma index, which actually just means the notes it's playing. So you can see here it's a chromogram of a C major scale. Then when you go from this middle C to C5, you see that it's octave independent, so it doesn't matter which octave you play it, it just gives you which note is being played. If you play them together, it will show. You see that we have this time. If you press the if you play a triad together, you will see there's 3 notes have a darker intensity over that amount of time. So yeah, I don't know if I explained it well. Sorry, I can't hear you. Next page. Okay, so here we define playing an instrument over a period of time as the ht function. Then we perform a Fourier transform on this function, so we can get a function of frequencies. So this ht is we are playing an instrument over a time period. Then when we perform this, we get this the third, this label 3, this equation label 3 is a form of discrete Fourier transform. Okay, you want me to explain this equation? The symbol V. Okay, in this case, V is the angular frequency of so it just basically mean the frequency. So the pitch we want to find.
Yeah, thank you. So thank you, Yongzhi. What? Sorry. Huh? What? Oh, why you study math? Sorry, I forgot.
Okay, in high school, I think math is my my best subject. So, and I enjoy doing it from time to time. But after studying math here, I'm a bit lost now. I feel like so I still enjoy looking at the proofs and something and so on, but I don't feel like that I have more passion than before. Yeah, but I'm still holding on, I think.
Oh, yeah, so I'm lost too. So thank you. Thank you, Yongzhi. So next we have He Yi. Okay, so if you have large noise, how you cancel those noise? So He Yi will tell us about the active noise cancelling in Apple Airport. Who have Apple Airport here? Huh? Oh, rich guy, huh? Rich guy. Okay.
Hello, everyone. I will share something about the Fourier transform in active noise cancellation. Noise cancellation headphones are frequently used in our life, such as Apple Airport. But do you know how to achieve active noise cancellation? Firstly, we need to pick up the noise signal through the microphone. Then we build a model based on the collected signal. We then pre-process the signal and use the appropriate Fourier transform. And you can see, using Fourier transform, we can transform the original function ft, which depend on time t, into a new function depend on frequency omega, such this. Then we analyzing the spectrum to estimate the spectral characteristic and energy distribution of noise. We choose the appropriate noise separation technology. Then we convert the signal from frequency domain back to time domain by inverse Fourier transform. Then we process the signal obtained from the inverse transformation. That's all. Thank you.
Does the airport self-send frequency to cancel it?
Again.
There are like a lot of noises, right, surrounding. So like you got like cutting grass sound or people talking, cancel out all the frequency, right? Send out one wave or many waves.
I think there are different patterns to win different situations. Actually, I don't know. If you want to know, you can try.
Be independent now. You should try. Okay, so Yanjing.
Math is my favorite subject in senior high, and also I think mathematics is interesting. Thank you.
More. Okay, so thank you, He. So next we will have Wensuo. Okay, Wensuo, kind of look forward to this talk. Visualizing frequency in music. So if you see the YouTube video, right, you will see the animation visualization. So he's going to talk about those things.
Testing. Okay. Good afternoon, everyone. Today, we will talk about music visualization with discrete Fourier transform and fast Fourier transform. And here are the definitions of these two transforms. So by applying FFT, fast Fourier transform, we can quickly convert music signal from the time domain to frequency domain, obtaining spectrum signal length and strength. Then we can make the x-axis represent the spectrum length and the y-axis represent the spectrum strength, and draw rays based on the two obtained data. In this way, we can get a simple animation, just like this picture. But by Python processing programming, we can easily apply the FFT and draw something colorful rays. So let's enjoy the short animation. I will try to play it. Hopefully it can be played. Gonna to show the whole video. Okay. Thank you.
Thank you. Okay, I got a question. So when you have the spike moving, right, does the spike represent the bass sound? Yeah, the spike.
Just like something like Yongzhi said, go to this picture. The spike just like actually the x-axis we let them represent some strength, just like some frequency just related to some page. If you like some page very low, the left part will goes too high. If you say something the page very high, the right part will be very high. Yeah.
So you make this graph into a circular graph, is it? So you join the highest part with the lowest part. Okay, sure. Okay, thank you. Question, Mingxiu?
Oh, testing. Okay, I actually write this topic in my first project of Calculus 2. So the discrete Fourier transform, just like just a discrete version compared to our continuous Fourier transform, you can see the sum notation this. And the fast Fourier transform just algorithm that that have very high efficiency to calculate the discrete Fourier transform. Both of them will convert some sound from time domain to frequency domain. Frequency domain. Yes. Thank you.
Okay, one more.
Hello, testing. Because you see some actually we reading or loading some music file. it's not always continuous. Actually, this is related to some topic about digital signal processing. So we processing signal, we need to split it. We can't processing it continuously. We need to split some and process it splitly. Yes.
Okay. Yeah, one more for AIT.
Yeah. So you mean what app? Like some? Oh, Shazam. Oh, no. This is not for identify what the song is. Just for some declaration, like some stage, like some music video, just like I showed before. Yes, I'm not sure. I think we can use this to compare some songs very similar and find this song is same as another song, so we can identify it. Use this. I think we can do this. Yes.
Do you have last word why you choose math?
Topic testing. There is a story behind this topic. Actually, I very like computer science, not math. But when I was training for an algorithm competition in my high school, my coach publicly criticized me because I have very poor performance in my math. So I feel very ashamed and frustrated in that time. I decided to major in math at my undergraduate level so that I would never be ridiculed for my math performance. Yes, but actually after 1 year study, I may transform my major to computer science because I think I didn't get what I want in math.
Okay, thank you, Wen Suo. So next up we have Xue Yan. Okay, Xue Yan about JPEG compression. Okay, JPEG. It's the theory behind JPEG compression. JPEG.
Hello everyone, my name is Huan Xueyan. Today I will introduce something about JPEG compression. JPEG is one of the image compression methods that can effectively reduce image size. This is where the Fourier transform be used. So I will introduce the principle and process of JPEG compression. Before that, we should understand what two-dimensional discrete Fourier transform. It's a transform that converts imagery from the spatial domain fxy to the Frankish domain fuv. The expression is as follows. At first, we need to segment the picture into A times A pieces following the standard of JPEG quantization matrix. Then use this transform to transform each pieces. And we can get the frequency spectrum. After that, we need to choose whether to keep the high frequency part or low frequency part, applying high passing filter and low passing filter respectively. And look at this picture. It's clear that we cannot suppress the low frequency component. In fact, the image information is basically represented at the low frequencies. Also, the final image will not be as clear as the original. This greatly reduces the space required to store this image. Okay, thank you everyone.
The JPEG stands for
It's a form of a picture. Format of a picture. Yeah.
Any question for Cheyenne? Any question for Cheyenne?
We first use the Fourier transform, this equation Fourier transform to get the frequency spectrum, and we can see from the frequency spectrum which is low frequency component. Because the size bigger than A times A, it's hard to compute, and the size smaller than A times A contain this information. So I think maybe people test a lot of times and get this conclusion.
Can you go back? Question, Homing. Okay, yeah.
And I think yes. Maybe yes.
Okay, thank you. So can you go back to a first slide? First slide. I have some. Let me see the first slide again. First, go back. Go back. Back. Yeah. So this slide. This picture is what? Is it Aristotle and? Yeah, I think this is a famous picture. I thought there's a special meaning for this. Okay, never mind. Yeah. So any last word you want to left for us? What is that?
Yes, because I think almost every major needs to study mathematics. So I directly choose mathematics. Okay, thank you.
Speaker. So next up, we have Suoning to tell us about image blurring.
Hello. Okay. Okay, I see. AIT student, listen carefully because you're gonna learn the convolution kernel in the year 3. Today I'm gonna talk about the application of convolution in age detection. So we basically have some questions like we use AI technology to search for things and identify things. So we may be curious about how the computer program to they identify things in the picture. Like they don't have the ability as human eyes. So how do we write the program? So we need some basic facts about the image. So first, fundamental unit of an image is a pixel. It's basically like the picture is discretized after it's taken. So the age becomes some pixels with some particular identities. And also we represent every pixel with a number from 0 to 255 or 8 ones in the binary value. This is some basic facts about image. Oh, and then, okay. Sorry, how can I go back? Oh, okay. So now we come to the theorem we use. It's a 2D discrete convolution. 2D discrete convolution, we can think it as a kind of you time two items in two matrices and add them up. It's like for X is from the first. Can I have a pen? Okay, we can imagine this is X we have, and this is W we have. So basically, for X, we go from that's first row, second row, and for W, we go from this to this, and we time the first with this, and this with this, and add up. Or also for the columns, we do the same. Then we add them all up. That's the 2D discrete convolution. And if we can see that the two infinite sum map up the all 2D 2D plane. If we do not want to map up 2D plane, that's also we can see that that means if X and W have finite dimensional, we only need to do that algorithm in finite many times. Yeah. Okay, thank you. Sorry, what point? That's to I mean map the if the two like matrices are infinite dimensional, we definitely need to yeah, that's a kind of definition. If we define this is 0, 0, then it's from minus infinity to infinity. Okay. Sorry. Oh yeah. Yeah. Sorry, what? Oh, because we. Yeah, because we for every pixel we just define it right with 8 digital binary numbers, and the maximum number we can store in the 8 digit binary value is 8 ones is 255. Yeah. Oh, okay. So it's basically from 0 to 255. 0 is the pure dark, and 255 is white. So when the number goes larger, the color becomes brighter. And also for that's for the gray images. That's and for color images, we have 3 inputs R, G, and B. Each of them has number of 0 to 255, which is the number goes to bigger and the color goes brighter. And we add up all them three, they come out get the color image. No way, 256 is 1 in the ninth digit and all 0. Yeah. I mean 256 is 1 in the ninth digit and all 0 behind. Yeah. So maximum is 255. Okay. Okay. Sorry. Let me finish all this. Okay. Okay. So maybe 2 sentences. Okay. Okay. The value of doing this 2D convolution. So we basically have W and X, two matrices we introduced before. If we see X as an input, because the dummy variable for X runs from IG to infinity, so that as an input is very reasonable. And W as a filter, that W is the value we need to modify X. So if we that is kind of like a weighted average for X. Just we do not weight it and we do not divide it by some numbers. Yeah. Okay.
Okay. Satisfied. Okay. Last word.
I need to answer the question, right? What? Why study math? Actually, I'm worse at math in my senior high. Yeah, so I want to improve it. That's the truth. If I cannot improve my math, I can't do many works in the future.
Okay, thank you for the speaker. Please clean out the board yourself. Okay, next, we have Liu Qing. Liu Qing. Okay, Liu Qing, tell us about MRI, magnetic resonance imaging. Okay, MRI.
Good afternoon, everyone. The subject of my project is utilizing Fourier transform for magnetic resonance imaging implement. Driven by the need for medical diagnosis, MRI technology is used to visualize the human body's tissue structures. So the problem is how to transform signals to an image. We can first extend the waves from 1 dimension to 2 dimensions as the given figure. And we call this type of wave a plane wave. Then we define plane wave as a formula. We can see from the formula that a plane wave describes a spatial domain signal and is composed of a superposition of plane waves in the x and y directions. Next, we extend the Fourier transform to 2 dimensions. We can finally get the formula of 2-dimensional inverse Fourier transform, and it is used to convert the spatial frequency domain signal into the spatial domain signal. As a result, we ultimately obtain the value of fxy at different positions. Then by assigning different proportions of black and white colors to different amplitude of the waves, we can then determine the grayscale values at each position, which forms an image. And that's all. Thank you.
Okay, thank you very much. Well, I was quite surprised. Yeah, so you speak well, write well. You should do it in the class also. OK，英奇有个 question 呀。
The special frequency domain signal directly from the human body?
No, the signal directly we obtain from human body actually is time domain signal, and we can use some other kind of technology to convert it to the spatial frequency domain signal that we need to use in this step. And yes, that's it. And actually, I was resigned to this major, so I didn't subjective to choose to study math. But I can share the reasons why I didn't choose to leave the major. I used to think mathematics is quite difficult and abstract, but after a year's studying, I kind of think it can be really elegant and practical in sometimes. Although the studying process is still quite challenging for me, but I can still feel a sense of achievement. And that's it.
Any more? Any more question? No more? Okay, thank you very much. Okay, thank you, Liu Qing. Next, we have Michelle. So Michelle will tell us about optimization of profit maximization in production functions. So there's some optimization problems here.
Good afternoon, everyone. Today, I'm going to talk about the optimization of profit maximization in a production function. So, first of all, the production function represents the relationship between input and output in the production function process. In any business, maximizing the profit is the primary goal. So, to achieve this goal, company needs to optimize their production process. So to optimize profit, we use the Lagrangian function which combines the objective function and the constraint. By introducing the Lagrange multipliers, we create the Lagrangian function. This function is then optimized using the technique like differentiation. Solving this optimizing problem provide the optimal input values for maximum profit while meeting the constraint. Then, to return to the original question, we use the Lagrangian functions to optimize profit, to balance the profit objective and constraint. Solving this problem, we could find the best input values for maximizing profit. Thank you. Yeah, of course. This Lagrange functions can use in maximize or minimize. So for Lagrange function, it is specific for multiple equality. So for more variables, it is also can use for this function, as it is focus no, it is for the more variables. If we have more variables, then we use this. It's more simple to solve our questions. So for our objective function, it is, for example, we want to find the maximum. Then we have a lot of equations such as 3x plus y. For the objective function, the constraint function means that we have the sums constraint that, for example, the budget and the technical, it will constrain our function. Therefore, yeah, this is the function of constraint. At first, I was interested in various number related industry. For example, data analysis, actuarial and finance, but I don't know what I really determined to a specific one. So I chose mathematics because this is the most fundamental and broad field. So I think if I eventually decide what I want to learn on the specified directions, I can, I won't be hard to start to the way in future.
We have Wita next. Adjust the structure of the portfolio to reduce risk. What are you trying to find? What are you trying to find? Huh? What are you trying to do? What are you trying to do? Yeah, I think should be inside this file, right? Should be in the file, right? Yeah, which one? What's the name? This one? Yeah. Is it? This is the part that link to calculus 2. So how you find those number you using partial derivative? Is that right? Uh-huh. Mm-hmm. Mm-hmm. Okay. 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 So excess contribution will tell you the risk. Okay. All right. Risk of. Okay. Sure. Okay. So we make the asset contribution less so that we can lose less money. Is it? So to compute asset contribution, you need the partial derivative on the variance. Is it? You need the partial derivative on the variance to calculate the asset contribution. Okay. Any question? No? Okay. Any last word before you leave the podium? Any last word? Why you so excited just now? Why? Do you love Max? Okay. Oh, I see. Okay. I thought you were gonna say I love money. Okay. Okay, thank you, Wei Zhe. So next, thank you, Wei Zhe. Next, we have Sang Er. So telling us about increasing power versus reducing drag coefficient using swimsuit in increasing swimming speed. So we're gonna see whether we need to increase muscle power or we need to reduce drag coefficient to swim faster.
Check. Okay, good afternoon, everyone. My project is focused on increasing power versus reducing drag coefficient using swimming suit in increasing swimming speed. Then this is the LZR razor. The LZR razor is the first using ultrasonic welding swimming green body suit created by Speedo. They have created this swimming suit in minimizing drag and maximizing support the muscle. The staggering number of world record and medal winnings by swimmer wearing this LZR razor. After that, the final ban the LZR razor in the future game because its take advantage too big. The speed of an object moved through water is 2p divided t and power to 1/3. Power is changed by x and the drag coefficient is changed by y. After reduce those functions, we will get the 1 plus x divided by 1 plus y power to 1/3 minus 1. This when the power or drag is in very big variations from 0 to 0.3. The powers need to increase by about 1.2 and the drag need to reduce by about 0.54. The reducing drag is about 2.2 times more efficient than increasing power. P is the power and K just the constant. C is the Bragg coefficients. Bragging you. But we need the swimsuit. I think is fast wearing the swimsuit. Without shirt, but need the shoes. Still need the shoes. Yeah. The main reason I chose math because in the secondary school, I like mathematics and enjoy the feeling after the solving the mathematic problem. Yeah. And those three science subject, I also not understand very well. So I choose math. Yeah.
Thank you. Next, we have Li Kai telling about shipping container or dumpster. Okay, how to use least money to build the most volume.
Hello, everyone. Hello. Hello, everyone. My project is about how to design a dumpster. Here are some conditions. Now we should design dumpsters whose volume is 40 meters cube. Here are the price of the material. The side, back, and the front of the front costs $8 per meter per square meter, including any required cuts or bends. The base costs $10 per square meter. These cost approximately $50 each, regardless of the dimensions. So, how do we spend the least time to build a dumpster? So to solve the questions, we should set up a model first. Yeah, it's obviously the dumpster is a box. Let the length, width, and the height of the dumpster be x, y, z. Then we can get the function and the equation. The function is about a volume. The equation is about the volume. The function is about the price, the cost. Our purpose is to find the absolute minimum of the function. So first we need to find the critical points. We can use the Lagrange method to find the critical points, and we can get these equations. Obvious these equations, we can get the 1 times x and 2 times y and 3 times z. The right hand side of the equations are equal, so we can get the general equation. So yeah. The reason why I study mathematics is very easy because I'm good at mathematics in senior high school. So, and mathematics is a fundamental subject. So I think it's very useful for my future career. Well, that's all. Thank you. Sorry? Because it's very easy. It's very easy and pretty and very useful. So it's still many money. It's still many money. Yeah. Yeah.
Thank you. So thank you, Lý Khai. Thank you, Lý Khai. So we'll have Ling Jing. Ling Jing talking about packaging optimization of canned beverages. Okay.
Hi everyone, I'm going to talk about the packing of canned beverages in our daily life. First, the many drinks are packed like this, and consider the transportation needs of the bottles. Someone designed the bottle like this, a cylinder, and its upper and lower diameter is reduced, and the bottom has a round surface toward inside. And then we try to use double integral to calculate the volume of the bottle. And for easier calculation, we split the area to these three parts, and then we got these three expansions.
Any question? Yeah.
Yeah. Let me see. This design can maintain the capacity of the bottom of the can to resist liquid pressure while reducing the material of the cans. Which design the bottom as a round surface into the toward the inside, and it can hold the liquids in the can easier.
Sorry.
The reason I study math just I have no idea to what I should study in the future, so I choose math. And in the other hand, I think this is give myself a chance to find more interest in math.
Okay. I have a suggestion. So try not to laugh too much during your presentation. Otherwise, it will affect your presentation. Okay. So thank you. Please turn off the mic. Yeah. Okay. Thank you. So next we have Yi Zhou. Yi Zhou telling us about the energy consumption in building. That's the 1,400 electric bill, is it? So
Hello, everyone. Today my project is talk about energy consumption in buildings. Energy consumption in buildings is an important issue, and the recent problem of electricity bills in the school has made our students feel puzzled and angry. So today I want to find out how to calculate energy consumption in buildings. Yeah. The salary I use is double integrals, and I use a simplified model to construct the energy consumption function. Assume the time variable and the space variable is t and s, and in the time period t1 to t2 with the volume with space size a, we can get equation. Yeah. The in energy consumption density function is too complicated, so I simplify it. Yeah. The energy consumption density function should be divided to two parts. One part is affected by the building volume, and the other part is not affected by the building volume. Then through a series of calculations, we could get the total energy consumption. I choose this topic because my electricity bills is doubled. So I'm puzzled. But double to W80? 80, yeah. Uh, I think math is a pure science that encourage me to learn about the nature. And in the high school, I'm good at mathematics, yeah. But in the universe, I'm a lot. I think it's difficult to me, so I'm try my best to study.
turn off the mic. Turn off the mic. Okay, thank you, Ito. So next we have Dong Jie, the last in our second slot. He'll tell us how the distribution in the height and weight in humankind. How's the distribution of height and weight in humankind?
Testing. In this project, we will use the definition of double integral to solve the problem to find out the probability of people being in a particular range of weight and height and the expected value of people's BMI. This is the definition of double integral.
and fxy is the joint density function for x and y. We can calculate this double integral to find the probability in a particular range of weight and height. And this is a method of calculating the expected value of BMI, which could be expressed as x over y squared. That's all, thanks. To tell the truth, I'm not very interested in math. Why I choose math? Because when I applied for the major, I don't know which major to apply. Others recommend me to choose math because it's easy to find a job, so I did it. I think the reason why I'm not interested in math is that my knowledge of math is too limited. And in the future, I will try to improve my math level and combine it with real life to find the fun of learning math. Yeah.
Let's have a break until 3:55. Okay, so we'll come back with Chi Fong. Okay, we have Chi Fong for the next speaker.
Testing. Hello. 太抽象的。Hello. Mr. Kissing so handsome.
你可以放大吗？你问一下。相称。他会讲话。哦，就这里放那个。我还是不知道他为什么有的时候底下会有这个什么。哦，为什么？有的时候为什么也明白底下这个为什么？有的时候哦 ，OK。这个按这个看，按这个能吗？对，可以看。这个。哇，现在被。
What time is it? Okay, 59. Let's start. Quick, keep start. Let's start. Start. So next up we have Pang Chi Fong. So ready your question, Pang Chi Fong. Accessibility RAM. 什么情况? Yeah. Okay, you may start now.
Okay, I'm going to talk about the accessibility RAM solved by the partial derivative. Okay, the problem is that accessibility RAM is an inclined plane installed in addition to or instead of stairs. They permit a wheelchair user and people pushing cars or wheel object. So we need to find out the best slope for disability and gradient of the surface where the slope is steepest. According to the website I found, the best slope is with 1 to 12 slope ratio, which means that 12 inches of RAM is needed for every 1 inches of rise. You may find on the website if you want. Then for the gradient where slope is steepest, the gradient number f function is a vector in a certain direction and let u be any direction, which is any new vector, and let the theta be the angle between the vectors, the function and the u. Then we have the equation as shown in the slide. And in our case, u is a unit vector and cosine theta is between -1 and 1. So the gradient f points in the direction of the greatest increase of f, that is the direction of steepest ascent. Alternatively, the opposite direction, negative f, is the direction of the steepest descent. So answer the question about why I first choose maths to study, because maths is the one of the subject I have interest, and I don't like coding, chemistry, physics, biology, and most of it. Okay, that's all for my presentation. Thank you.
Okay, thank you. Very short and sweet. Okay, any question for Chi Fong? Question, Karen?
Okay, it can be. I want to use the Pythagoras theorem to find the slope ratio, but it's not in my syllabus and I don't want to find it. But I found on the ADA website, so it's provided by the government. So they say that it's the best slope ratio lah, but it's for commercial RAM only. If your use for your house for Spain is limited, so it's for 2 to 12 slope ratio. It can be used to find by other knowledge, of course, but not in my presentation. Any other implementation? Like wheel object like cars or your trolley, like you need to push something up. You cannot using stairs. I can't push you up to the stairs, right? Like using a ramp. Or you roll up the stairs, you cannot. You roll rush ramp. You want me grab you lah? Okay, no problem. Yeah, it's a back because the angle is small. Like even though the length is long, but it's effortless. Not because if you get stepper like almost like 90 degrees, you won't get up. So like if it's like this step, so you may go up effortless. Okay.
Yeah, so we have next speaker, Jingbo, will be doing the design of roller coaster. So we move the ramp into a roller coaster.
Hello. Good afternoon, everyone. I'm going to talk about my project. Basically, my project is about the concept to construct a smooth roller coaster in 3D. I believe that most of you are familiar with roller coasters. It's an elevated runway with steep inclines and descents. And the figure shows a simple modeling of a roller coaster. To build a roller coaster, we'll use a continuous piecewise function. Next, I will introduce two terms first. The equation of degree n directional derivative of a function in the direction of any unit vector is shown in the equation above, and the polynomial function of degree n in two variables is shown in the equation below. Then we need to have a continuous directional derivative of the piecewise function. As shown in the slide, continuous higher order directional derivative will make the roller coaster smoother, and higher order polynomial function will have a continuous higher order directional derivative. So our goal is to construct a higher order polynomial function when building the roller coaster. And that's all of my project. Next, I will simply talk about why I first choose to study math. I think it's just I feel interested in math, and my math result is the best among all the subjects. So I logically conclude that I should study math at the moment when I need to do the choice. Maybe now I don't think so, and sometimes I regret to study math, but I think it's a normal thing because it is a human nature. In our life, we will love a lot of things, we will like a lot of things, but unfortunately, we will love something for a duration only. After this duration, we'll decide this thing or even start to like new things. So I think it's not your fault to not like math at this moment, especially a lot of assessment is going on. But for me, I will still study math because this is my choice and I need to keep my pension and be responsible to my choice. And thank you.
Okay, thank you. If you wonder why he talks so much, because he's the monitor of this class. Okay, so I like your slide a lot. Any question for Jingpo? Any question for Jingpo?
What do you mean? Is it safe to my aim is to build a smooth roller coaster, but I don't think I will consider the safety. I think it's another concept because I said I will construct a smooth function only. Because behind the roller coaster we have a lot of concept like the safety, the for load we have centripetal force, and a lot maybe for my design for smooth roller coaster, when going down the force is not enough to going up. As so there is another concept that need to be further studied. Because we got a lot of runway, like a lot of different runway, different shapes. So for example, for example, for this one, we cannot use to three piecewise function for going up, going like quadratic function and the going down function. So we need to connect them. We cannot like simply use a function. We need to use a lot of functions, so we have a piecewise function. Yeah. Yeah. I will give my project to physician. Uh, Another, your question is
Testing. Okay, thank you, Jimbo. Next, we have Ying on the menu. Ying will talk about roller derby. So if you roll two things together, so which one reach first? Okay.
Hello. Testing 1 2 3. Okay. Hi guys, I am Yin. And firstly, let's take a look on my problem statement. Assume that a solid ball and a solid cylinder with the same mass and radius is rolling down an inclined plane. Which object will reach the bottom first? Actually, after doing some interpretation to this question, we will know that in this case, the object with the smaller moment of inertia will move faster. Next, let's introduce a formula which apply triple integral to find the moment of inertia of the object. For a solid object that occupies a region of E, which have a density function of rho in unit of mass per volume, the moment of inertia of the object about the z-axis is the formula shown as a slide. Next, we can apply this formula to find the moment of inertia of the solid ball and also the solid cylinder. And after the calculation, we will find that the moment of inertia of the solid ball is actually smaller. This implies that the solid ball will move faster down the slope when compared to the solid cylinder. Therefore, the spherical shape is a better shape design to move down the slope faster. And so, multiple integral is very useful in our daily life since it can help us to determine the best design for the object. And then this is all for me for my presentation. Now I would like to talk about why I study maths. Basically, I study maths is to strengthen my critical thinking and mathematical basis so that I have a greater ability to perform complicated tasks when I study data related field in my postgraduate study. And actually, this is all for me today for my presentation. And now let's begin my Q&A session. Do you guys have any problem to ask me? Please feel free to raise your hand. I will answer your question. Huh? Okay, actually, I have do some research on the multiple integration topic, and then I have sent to Professor Kising. Actually, this topic is suggested by ChatGPT. That topic is suggested by ChatGPT, but Mr. Kising said that he's scared that this topic is not relevant, so he called me to refer to the textbook to see some example of some example of multiple integral question. And after that, I see this question is quite interesting, so I do this topic. This is the reason why solid ball will move faster down the slope when compared to a solid cylinder. Yeah. Yes, my lovely friend Hongming. Actually, this is the assumption of the slope is straight line, so we can use the moment of inertia case to determine, because in this perfect situation, the moment of inertia is proportional to the time taken for the object to move down the slope. However, in the case of a curved plane or what, that moment of inertia, the effect of moment of inertia will be different. So it must be considered as different situation. Huh? Then I need to do some further derivation for this. Because this derivation is actually based on the slope is the slope is smooth. Okay. Huh? No. I mean the plane is straight. Sorry. Do you guys have any other question?
Thank you very much. Thank you very much. Mike. Thank you. Okay, thank you, Wayne. I should hire you as a moderator next time. Because you kill yourself. Okay. So next we have Inchi to talk about speed camera on a mountain corner road. So okay, see you. Thank you for coming. Thank you for coming. Bye. Safe flight, safe trip. Safe trip. Okay, Inchi.
Hello everyone. The title of my project is Calculus in Warning on Mountainous Roads. We all know that if an object undergoes circular motion and its speed is too fast, the frictional force it receives will be unable to spot it as its centripetal force. Consequently, it will derive and result in a real-life scenario known as a car overturning. To figure out the problem, let's introduce some formula. For example, the formula to calculate the derivative k, the formula radius, and the arc length. But only using the mass formula is not enough. By connecting it with the calculation process of physical acceleration, we can use the friction coefficient, and then we can figure out A equals to mu g. Because we know that when the pressure remains constant, the frictional force exerted on an object has a maximum limit. And finally, we can figure out the maximum value of V. In conclusion, the differential equation of the curve enables us to determine the radial radius of the car, and the facial formula allows us to establish a connection between the curve and the ground. It has some applications in real life, for example, the Delphi technology. It is an automotive component supplier that offers various advanced driver assistance systems. And by using this technology, we can avoid a lot of car crashes in the mountainous roads. Thanks.
Question for Inchi. Yep.
Did you decompose the acceleration of the car into orthogonal components? For the orthogonal decomposition of acceleration, it can be divided into tangential and normal components. Let us see. Okay, why I can't? Yeah, that we can denote it as A tau and AN. It's a physical method to solve it. Okay. So why do I study math?
Yeah, okay, yeah.
And I think the first reason is, yeah, totally because of interest. I think it's a good tool for us to understand the functioning behind everything. And it is also a good discipline for us to know about the world. And the second one, I think in the study field, there is no statements like both this and that are right. I totally appreciate the straightforwardness between black and white. I think arriving at a correct answer gives me a sense of joy and satisfaction. And the third one is because of study math can help us find a good job. It's yeah, that's all right.
Okay. So next we have who is the next one? So next one is who's the next speaker? Jia where's Jia? Jia, yeah. So Jia. So Genting Highlands route calculation. So who wants to go on Genting Highland? Huh? Okay. First day for holiday. Sure. Ah. Why? What pen? Marker? Time start, time starting. Yeah, time starting now.
Test. Oh, okay. Hi, everyone. Today we talk about the GPS calculating the mountain routes. In spherical coordinates, we know that the x, y, and z can express in the very different forms. At the same time, we note the arc length of the in the 3 dimension to be the depth formulas, and as we all know, the graph of our functions, if it will be aligned, it will be only one variable. So we need to express r and phi by the thetas, and we got these 3 formula and the range of the theta. And after the simplified, we can change the original formula into the final one. And we're taking the Genting Highland as the as an example. It is difficult to parameter the routes by the variable t, but it's easier to model with the spherical coordinate. And we can substitute the data into our formula, and we can simply get our outcomes. That's all. Thank you. To be honest, if you understand the history of the physics, you will find the development of the physics often based on the theoretical inventions in mathematics. So even many physicians are also themselves the mathematicians. So if I want to learn the physics successfully in the future, I have to choose math first. It is a way to calculate the total length of the routes in the such like the mountain routes. But if it will be a straight line, it will be another simple way to calculate. This is always a function to calculate the mountain route. I don't know, but it can be a way.
Oh, testing. Okay, good. Thank you, Jia. So next we have eating. Tell us about the Kepler's law. We're going to space again. Outer space.
Hello everyone. My topic is about Kepler's laws. First is the introduction. Kepler's law is the law of planetary motion discovered by the Germans, astronomer and mathematician Kepler's. Kepler's second law states that the line joined to the sun to the plane sweep out equal area in an equal time. It can also say the derivative of area respect to the time is constant. And I will prove this result in this project. R is the position vector in this of this plane, and U is the unit vector in the direction of R's. And use these two laws, equating and equating the equation 1 and the equation 2, we get equation 3, and dividing both sides by arm, we get we can see the equation C. A is a parallel to R's, so the cross product R cross A is the zeros, and the derivative R cross V is also zeros. So the R cross V is constant vectors, and we use the angular momentum of the planes. There are two expressions of the angular momentum. First is R cross P, and the second is I times omega. No. 3 yes. Not quite. I'm not understand your question. Okay. Okay. Yes. Why study math? Oh, okay. For the reason why I study math, because I'm interesting math in my high school, and sometimes I enjoy the process of solving the problem, and if I can choose the project that I'm really concentrating on, then the math is the one that I can choose. Yes.
Next, we have Zhen Chen. Zhen Chen telling us about orbit of Mercury. So orbit of Mercury is a kind of fascinating subject because it violates the Newton's law of gravity.
Hello everyone, my topic is about Mercury's orbit. The Lagrangian for Mercury's force-free motion. The equation for Mercury's related perihelion position per orbit is this equation. And for this equation, using a value from NASA's solar system body's Mercury's website, we can get a perihelion shift of 42.9 seconds for arc per century. And the Lagrangian for Mercury's force-free motion is given by the following equation. And the Biot equation is about Eulers Lagrangian equation. And using these two equations and another complicated physical and mathematical calculation, we can get the Biot equation. This. And this is a figure about Mercury's orbit. Thank you.
Done?
So why I study math just because I want to be engaged in finance in the future. And learning math can strengthen my mathematical basis. And so I can do well in the future for my finance job.
Venus to tell us about orbit of Venus.
Hello. Okay. Good afternoon, everyone. My name is Kanabaita Ueda Venus, and I'll be presenting on the applications of calculus in astronomy, i.e., the orbit of Venus. So I wanted to give you talk a little bit about Venus before I start. So yeah, Venus is the second planet in the solar system. It's right before the Earth. And she's sometimes referred to as the Earth's sister due to their similarities in mass and density. Planet Venus rotates backwards, which is opposite to most planets how they rotate. It has a clockwise direction. Okay, so the problem statement. So in the olden days, when many scientists were curious about our solar system, sky objects, etc., determining the object of different planets was one of many goals that they had. And in this presentation, we're going to basically show a little bit of how calculus can be used to compute the orbit of Venus. Well, briefly. So to derive the orbit of Venus using calculus, we can start with the fundamental principles of celestial mechanics and apply Kepler's laws, which were talked about one of the presenters before me, of planetary motion. Kepler's laws describe the motion of planets around the sun based on the gravitational force between them. Okay, so from Kepler's laws of planetary motion, we can get that the orbit of Venus is an ellipse, which can be described by this equation in polar form.
Time's up. Venus. Any question? Question for Venus? Any question? Yeah. So do you want to have some last word before you go?
Okay, so why do I study maths? Well, it goes way back because before studying math, I did computer science for 2 years here in Xiamen. And when I decided to drop it and do math, it was because I didn't really like much of coding. And after my first year, even I wanted to transfer, but the concept of transferring and starting over it's a bit scary. So I didn't. But mostly, I will say the reason why I study math is because I like the fact that math is exact. You only get one answer. And I like the fact that there's are many ways to that one answer. I can solve a problem, you can solve a problem. We use two different ways and we still get the same answer. So this can be used in life. I have my own path in life, you have your own, but we can all get to success, basically. Thank you.
Thanks, Venus, for sharing. So next we have Yuwei. Yuwei will tell us about the design of the low thrust Van der Waals trajectory.
Okay, that's my turn. What I want to introduce today is applied mathematics in low trust trajectory optimization. So we know that in the preliminary stage of space measuring design, the estimation of the fuel consumption and the trajectory is an important part. In order to better design the orbit, we can use the mathematical method. So to well design this curve, in 2D, we always use the polar curve or parametric equation to represent the curve, and always in 3D, we use the spherical and the cylindrical coordinate, right? And so we in here, we take the parametric equation to present the orbit, then we can obtain these two formulas by Newton's law. But it's not enough, right? We need to enhance it to the 3D part. So we add the x-axis. This is what we get. Based on it, we built the Fourier series and combine with the front of the equations, we can get these coefficients, and that's what we want. And we check the Fourier series for the RT and the theta t, then we import the previous obtained equation into this equation, and we can get these coefficients. Then we can plug in the parameter and this pH. This is what we want. Okay. Then we will talk about why I choose the math. Okay. A large of reason for this matter comes from my eyes. Actually speaking, I prefer chemistry to mathematics, right? But I'm color weakness. Just I can't see where it's red or it's green. So I can study the chemistry. It's a big reason why I chose mathematics. But having said that, I like mathematics, especially when it's applied. It makes me feel very interested in at this time. At the same time, I think math is a conversion between definitions, and many things need a mathematics definition to be used, such as physics, biology, computers, AI, and etc. So I believe that mathematics is a good choice when I want to continue on the path of mathematics or change my major in the future. These are the most the reason why I choose mathematics. The first line, this one. Angle. The theta f is the final angle. We can see this one. There is the theta, right? F is the final angle, and if we check the theta I is the initial. How to see S stand for? So what mean? Oh, it's it means that it's in this coordinate, right? The spacecraft, the initial point to the final point is the angle between the x1 and just we learned in the cylindrical coordinate. Because we can see that spacecraft in the our space, right? Its orbit is like oval, right? Ellipse. Yeah, ellipse. So it's better to use a cylindrical to represent this one. And also, we can see if we use a spherical coordinate, right? There is two is theta and the phi. We need to get. And if we use a cylindrical coordinate, we just need 1 theta. It's faster to calculate.
So Yinbo will tell us about balancing stun, the one that I suggested. Balancing stun.
Hello. Today we are going to talk about the art of paddling a umbrella, and analyze the mathematics behind it. To analyze the acrobatics, we need to find the center rate of the umbrella. Now let me introduce the center rate coordinate theorem formula. Let's consider a three-dimensional object with a density function f, x, y, z. The mass distribution along each axis we need to calculate the mass distribution along each axis and divide by its total mass. The mass distribution along the x-axis can be expressed as this formula. And now the center coordinate x bar can be calculated by mx divided by its mass m. In a similar way, we can get the center coordinate y bar and z bar. This is the formula. Now, let's consider the problem. Given the density function is this, and this is its graph. Using this formula, we can find the center rate coordinate 0, 0, 0. And we can treat the umbrella as a point mass at 0, 0, 0. The up arrow is the support force and the down arrow is the gravity. Okay, we can. This ensures the stability of the umbrella and prevents it from toppling over. Question. Okay. I study max because I don't like the art science art subject because the answer is always changeable, not certain, and the math answer to a math problem is always certain. You can always get only one answer. Every time after I solve the complex math problem, I will feel a sense of achievement. Interest that motivates me to study math. Okay, thank you.
For the next, Tanya will tell us about the steelyard weighing scale, the traditional weighing instrument. How does it work?
Good afternoon, everyone. My project is about stelia, a traditional Chinese measure tool. The question is the density of the stelia is uneven, but why the scale distribution of the stelia is uniform? Since the mass of an object is equal to the value times density and the stelia is a cylinder, so we can use triple integer and level balance to solve this question. In situation 1, we can simplify the model. And everything in the graph is known. By leverage balancing, we can get the formula 1. Then, when the stelia has objects and in balance, we can get this new formula 2. By making the difference between 1 and 2, we can get the expression 3. Then we change the mass of the object to km. Then we get the formula 4. Eventually, from the 3 and the 4, we get the formula 5. Here we arrive at the conclusion. That's all. Thank you. Okay. The reason is very simple. I was interested in mathematical in my high school, but to be honest, after I know my Gaokao result, I know I will learn it. If my Gaokao result is better, maybe I will learn economy. Thank you.
And the second last speaker, Pishon. So Pishon will tell us about fluid force in a spherical submarine.
Test. Okay, so on this occasion, I would like to present my project about fluid force on spherical submarine. So why study math? People say that math is hard, it's tiring, it's confusing, and have no real life use. But have you ever considered what would happen if people never study math? This happens. This is a recent news. I think most of you already know. So I'll talk about fluid force on spherical submarine. Fluid force is a force that exerted by fluid on an object that is under or inside in the fluid. So here's like some physics formulation about force and pressure and area. So problem statement. Suppose we have a sphere-shaped submarine and the radius of that submarine is r, and the distance from the water surface into the center of the sphere is hc. Now we want to find the fluid force that the submarine needs to withstand. Okay, so we have this. It's easy, right? We just need to like substitute the area and then put in the hc and we are finished. Wrong, it's not finished. It's more complicated. We need to consider like small differential area dA such that we have like dF equal to this formula. Now, in order to compute all